Hey learners, welcome to Mac. So learners, in this video, we will see a problem which can be solved using the concept of sliding window protocol. So learners, see here, here's the problem. So we are given an array of n elements and a number b. So we have to return minimum number of swaps to bring together all numbers less than equals to b. Okay, suppose here is an example of an array. There are some elements. Here b is given as what? 8. So we have to bring together all numbers less than or equals to 8. So what we can do, that we can just swap 1 from this 10 and 5 from this number 40, and with that all these three numbers will be together. Okay, what else we can do? We can just put swap 3 with this number and 1 with this number. With that we can just all the three numbers will come over here. Or else what we can do, you can just put 5 over here, swap 5 with this number, 1 with this number, this with this also, all the three numbers will come together. So in whatever way you just swap all these, so the minimum number which can be there for the swapping to bring together all the numbers which are less than equals to b are what? 2 only. You can see in this problem there the answer for this is what? 2 only. So here is also another problem. You can see here the number given b is as what? 10. So what you can do in this set of elements? In the set of elements, if you just swap 3 with here and 4 with here, then also all this number will come over here. One thing you can do, that you can just swap 4 with here with this number, then all the numbers will be there, will come together. So if you just swap 4 with this number, so the minimum number required for swapping is 1. So we have to get the minimum number of swaps. So for this problem the answer will be what? 1 only. Okay, so what can be the solution for it? There must be a solution, and in this problem we are going to use the concept of sliding window protocol. Just see a solution for that. So first of all, what we will do, we will just count the number of elements which are less than equals to b. Okay, so such as in this set of elements, the number of elements which are less than equals to b are what? 1, 2, 3, 4 and 5. So there are 5 set of elements which are less than equals to b. Okay, and thus we'll store this in a variable. So now we have to just make a length of the final answer group, which is what? C only. This is the count of elements which are less than equals to b. So now just consider that all the numbers which are less than equals to b are good numbers, and all the numbers which are greater than b are bad numbers. Okay, so we have to swap with the same number as the number of bad numbers in the answer group or the window, which will be of the size c, the count of elements which are less than equals to b, say. Okay, and with each iteration we will just move the window and calculate the number of swaps, and in each iteration we will just see that the number of swaps in this iteration is is the minimum as compared to the previous one or not, and we will just get the previous one and we will store that answer. Okay, and then we will just return the result. Suppose, okay, see the number here, the example. Suppose here is the same array, b is given what? 10. So what are the number less than equals to b? I have just highlighted with the green color. You can see 2, 7, 6, 9 and 3. So these are the numbers which are less than equals to b, and so these are good numbers, and suppose the number which is greater than b a bad number. So I have just highlighted with this as with the red color. You can see this and this. So the size of the window is what will be then as the count of the number of elements which are less than equals to b. Okay, you can see over here, first of all we have to count the number of elements which is less than equals to b. So first of all we have just counted the number 1 2 3 4 5. So the size of the window will be what? 5 only, as the length of the answer group equals to the just count of the number of elements less than equals to b. So now we will just make a window of the size 5 starting from 0th index. Okay, so we have just make a window of the length 5. So in this window you can see the number of bad numbers are what? 3 only. So for the first window we will just calculate the number of bad numbers. Okay, then for this window the answer will be what? 3. So 3 swaps for this window. If we swap these 3 numbers with the good number, then all the good number will come together. Okay, now just move this window towards the right side. Okay, now see over here, we have just moved the window towards the right side. So when we have just moved the window towards the right side, this number is out, which was a bad number, is out, and in this video there are no extra bad numbers are added. So so previously the bad was 3, so one bad number is removed, so -1, and no other bad numbers is added, so +0. So for this window the number of bad numbers will be what? 2, and for this answer it will be 3 only, sorry 2 only. Okay, it was by mistake. So for this window the answer will be 2. The number of swaps for this window, just if you swap these 2 numbers with the good numbers, then this in this window all the good numbers will come together. So now just see when we shift this window towards the right side. So okay, now just see over here, when we have shifted this window towards the right side, now one bad number is out. Okay, and no another good number is added in it, no extra good number is added. So you can see previously the bad was 2, so one bad number is out, so -1, and no extra good bad numbers is added, so +0. So answer will be 1. So answer is 1 for the number of swipes in this window. Okay, so now just shift this window towards the right side. Okay, so if you shift this window towards the right side, you can see that there is no bad numbers is out. Okay, since it was a good number, so no bad number is out, but one bad number is added. Okay, so you can see over here in the bad, previously it was 1, no bad number is out, so -0, plus one bad number is added, so +1, so it will be 2. So the answer for this window will be what? 2. 2 will be the number of swipes for this window. Okay, now just shift this window towards the right side, and we reach the last element, and in this video you can see one bad number is out and no extra bad number is added, no extra. So bad previously was 2, so 2 minus one bad number is out, -1, plus no bad number is extra added, so +0, so it is 1. So answer will be what? 1. So 1 is the number of swaps for this window. So you can see in all these swaps, here we get the answer as 1, and also answer is 1 here also. So when compared with all the iteration, when the window is moved towards the right side, and the answer is we get the minimum is 1 only. Here we are also, here we are getting 1, and also here we are getting 1. You can see here. Okay, so the minimum number of steps for this problem will be what? 1 only. So with this we can just get the minimum number of steps required to get all the good numbers together. So now just see a pseudocode for it, with which you can just solve a coding problem based on that. Okay. So here you can see here is a method min swaps, which are taking two inputs as an integer array and int b. So first of all we are taking n as the length of a. We are initiating k with 0. First of all, now we have to count the number of elements which are less than equals to b, and the time complexity for it will be what? Order of n only. So here is a loop which are starting from I equals to 0 to I is less than n and I plus plus, and we are checking that if ai, so the element of array a of index I is less than equals to b. So if it is true, we will increment k, and when this loop ends, we will get the value of k, the number of elements which are less than equals to b. So now here we will check that k is equals to 0, or if k is equals to 1. If this is it, then we will return 0, as even if there is a single element, so we don't need to do any number of swaps to bring together all other elements. So for this we will return 0. If it is greater than 1, then we will move forward. Here we are initiating bad variable with 0. Okay, now first of all we have in the first window we have to count how many there are bad numbers. So for I is equals to 0, I should be less than k and I plus plus. So for counting this number of bad numbers, so here we are checking that if I is greater than b or not. If it is true, we will just increment the bad variable. Okay, so when this loop ends, we will just get the number of bad numbers in the first window. So now we will apply the sliding window protocol over here. So here we will initiate the answer variable which equals to bad, s equals to 1 and e equals to k. S is the starting index, e is the ending index. So now here we are initiating a while loop. E less than equals to n is the condition over here. So here we are checking that if the array element of a s minus 1 is greater than equals to b, then we will just decrement the bad variable, and if array element of e index e is greater than b, then we will just increment the value of bad. So in the answer, after that in the answer, we will just take the minimum of answer and bad, and after that whatever will be the minimum value, we will just put at that in the answer variable, and after that we will just increment s and e, and this loop goes on till e reaches the last element of the array. Okay, and at last we will return the answer. Okay, so you can see, you can compare it this pseudocode with the number of steps you go over here. So first of all you have to count the number of elements. So here you can see we are counting the number of elements. After that we have to make a window of the number of elements with the c only. Then first of all the window is made with the and the number of bad numbers is counted. Okay, and we will just move the window and calculate the number of swaps. So here we are applying the sliding window protocol, and we are just counting the number of swaps for all the windows which are shifted towards the right side for the each iteration. Okay, now just see the time complexity for this problem. So first of all, you can see in this loop, this it runs for n times. So for this loop, the time complexity will be n. Okay, now this loop will run for k times. You can see k is here. So from I is equals to 0 to k, so this for time complexity for this loop will be what? K only. Okay, now see over here. So this loop runs for what? N minus e, and e is equals to what? K only. So n minus k. Okay, here by mistake it is 1, so I will just remove it. So it will be what? N minus k only. Okay, so finally the time complexity will be what? First of all, with the first loop it will come n plus k, and after that plus n minus k, n plus k plus n minus k, and this one will be removed. Okay, and this will result in finally what? Order of 2n plus 1, which finally is the order of n. Okay, and in this solution there are no extra array or any other thing is added, so the space complexity will be what? Order of 1. So with this we get the solution with the optimized time complexity, and we are using the sliding window protocol in this problem. With this we reach the solution with the help of sliding window protocol, and we have seen a good coding problem based on sliding window protocol. So this is it for this video. I hope you have understood this problem. So if you haven't understood, if there is some question, so kindly put it in the comment box, and if you have to give any suggestion, okay, please comment out there only. And if you like this video, just hit the like button, do subscribe to our channel, and hit the bell icon. Thank you.